Welcome to The Explainer. Today we are diving into one of the most important concepts in all of programming, control flow. This is the stuff that lets us give our code a mind of its own, turning a simple list of instructions into a program that can actually think and act.
So let's start with a really basic question. Have you ever looked at a complex app or a website and felt like the code behind it is actually, well, thinking? You know, like it's making smart choices all by itself.
Well, here's the surprising part. Out of the box, it's really not. By default, code is just an incredibly obedient follower. It gets a list of things to do, and it just does them, one by one from the top of the file to the bottom. No detours, no questions asked.
So how do we get from that simple follower to a dynamic problem-solving powerhouse? Well, we give it a toolkit that acts like a brain. And that amazing toolkit is called control flow. Let's see exactly how it works.
Here's what we've got on tap for today. First, we'll talk about how code makes decisions. Then we'll get into repeating actions and looping through data. We'll also see how to handle the unexpected when things go wrong. And finally, we'll put all those pieces together to build our very first smart program. All right, Section 1, Making Code Smart. Let's start with the fundamental idea here.
You see, control flow is what completely shatters that top-to-bottom, line-by-line execution. It lets a program pause, look at a situation, and decide, should I go down path A or should I take path B? It basically turns your code into a choose-your-own-adventure story where it can jump to different pages based on the choices it makes.
So, Section 2, Decisions, Decisions, Decisions. This right here is where our program's intelligence really begins. Let's teach our code how to make its very first choice. The most basic, fundamental decision-making tool we have is the if-else statement. Think of it as a simple fork in the road. If a certain condition is true, like say if a user's age is 18 or older, it does one thing. If that condition is false, it does something else entirely. It's the classic yes or no question of the programming world.
Now that standard if-else block works just fine. There's nothing wrong with it. But for these simple choices, programmers often love a really slick shortcut, the ternary operator. It lets you ask a question, then provide the two possible outcomes all in a single, super clean line of code. It does the exact same thing, just with a lot less typing.
Okay, but what if you have a whole menu of options, not just a simple yes or no? For that, we bring in the switch statement. It's perfect for taking one variable and checking it against a whole list of possible cases. Now, the break keyword here is super important. It tells the code to stop as soon as it finds a match, so it doesn't just keep on checking the rest of the list. And default, that's our fallback plan. It runs if none of the other cases match up.
So our code can now make choices. Awesome. Now let's give it a real superpower, automation. We're going to teach it how to repeat actions so we don't have to write the same lines of code over and over and over again.
The classic for loop can look a little intimidating at first glance, but really, it's just three simple parts. First, you have the initialization. That's your starting point. Then you have the condition, which tells the loop when it should stop. And finally, you have the increment. That's what happens after each time the loop runs. So in this case, we start at 0, we keep looping as long as our counter is less than 5, and we add 1 to it each time. Simple as that.
We've also got while loops, and these are really handy when you don't know exactly how many times you need to repeat something. A standard while loop checks the condition before it ever runs, so it's actually possible it might not run at all. The do while loop, though, is a bit different. It runs the code block first, and then it checks the condition. And that guarantees the code will always execute at least one time.
Section 4, Looping Through Data. And this is important because loops aren't just for counting numbers up or down. Their real power comes alive when you use them to process collections of data, like a list of items you get from a database. Let's see how that works. The for of loop is honestly an absolute dream for working with arrays. Instead of having to set up some manual counter, you can just tell JavaScript, hey, for each item of this list, do this thing. It just pulls out each value, apple, then banana, then cherry, and lets you work with it directly. It's so clean.
And what about objects, with their keys and values? Well, for that, we have the for in loop. This one is a little different. It goes through the properties of an object.
giving you access to each key. So in this example, it would give you name and then age, and you can then use those keys to get their value.
So with all these options, how do you choose the right loop? Well, it all comes down to what you're trying to do. If you know you need to run something exactly 10 times, a classic for loop is your best friend. If you need to loop until a certain condition changes, while is the way to go. If you're grabbing values out of an array, for of is the modern, super readable choice. And for checking the properties inside an object, for in is the tool for the job. Picking the right one really makes your code way easier to understand.
Section 5. Handling the unexpected. Okay, so our program can make decisions. It can automate tasks. But, the real world is messy. What happens when something totally unexpected goes wrong? Like trying to work with corrupted data from a server.
For that, we build a safety net, and we do it using a try-catch block. You wrap any code that might fail inside the try block. Think of this part as the high-wire act. If an error happens, the program doesn't just crash and burn. Instead, it jumps immediately to the catch block, which is your safety net. And the finally block? That's the cleanup crew. It runs no matter what, whether the act succeeded or failed, to make sure everything is tight.
All right, Section 6, your first smart program. We've covered decisions, loops, and handling errors. Now let's put it all together and see how these building blocks create real, smart, and robust logic.
Here's that conditional logic in action. The function first checks, is this number greater than 0? If it is, boom, we're done. We return positive. If not, the code flows down to the next check. Okay, well, is it less than 0? If that's also false, there's only one possibility left. It must be 0. It's a simple, logical waterfall.
And here's a beautiful example of a loop and a conditional working together. A for loop is methodically counting from 1 to 10, but inside that loop, we have an if statement that's filtering. It's asking, is the current number evenly divisible by 2? Only if that condition is true does it actually print the number. This is how you sift through data on the fly.
And finally, here is our safety net in the wild. We try to parse a string of data, hoping it's valid JSON. If it is, fantastic, we can use the data. But what if that string is messed up? Well, that parse command is going to throw an error. But instead of our entire program just crashing, our catch block grabs the error and lets us handle it gracefully, maybe by logging a helpful message to the user.
So, that's control flow in a nutshell. We've seen how to take our code from being a simple line-by-line follower and transform it into a program that can make decisions, repeat itself, and handle errors with grace. These are the absolute fundamental building blocks for giving your code a brain. The only real question left is, what are you going to build?